This video is looking at stoichiometry involving gases. As with our other stoichiometry problems, there's 4 basic steps. Step 1, write the balanced chemical equation. Step 2, convert whichever thing you know enough about to moles. Step 3, use our mole ratio to determine moles of unknown. Step 4, convert to desired units. With these steps 2, 3, and 4, sometimes we are able to do those steps using dimensional analysis. Sometimes we may need to use some of our equations that we have for our gas laws, depending on what our given information is and what information we need to know. So our first example here, we have zinc reacting with hydrochloric acid to produce zinc chloride and hydrogen. So our reactants and products: zinc plus HCl for hydrochloric acid. Don't forget that hydrogen is H2. Zinc chloride, balance the charges to get that. Now that's not a balanced equation, so we need to balance it. So we've got twice as much hydrogen and twice as much chloride on the product side as on the reactant side, so we need a 2 here to balance our equation. So there's our step 1. We've got our balanced equation. In order to do step 2, convert our given amount to moles, it's a good idea to figure out, well, what do we know moles of? Or what do we know enough about to find moles? So our given information, we've got 5 grams of zinc. And our unknown is that we're looking for the volume of hydrogen. So if we look at that, that's useful, but we also have another piece of information that we should identify, and that's this SATP. So that's going to be important when it comes to calculating volume of hydrogen. So let's put it with our hydrogen. So if we want to do this calculation, convert our given amount to moles. Well, we've got grams. If we want to find moles, and I just realized I've got my grams on the wrong thing here. If we want to figure out moles, we're going to have to divide by the molar mass. So for zinc, we can look that up. It's 65.39 grams in 1 mole. Remember, we want to cancel out our units when we're using dimensional analysis, so our grams here are canceling our grams here. Our next step is convert to our unknown, right? Use our mole ratio. So in this case, our ratio is going to be between zinc and hydrogen. We want to get rid of zinc, so it goes on the bottom. Hydrogen goes on top. And again, we can look at how these things cancel, right? It's our substance canceling this time. So now we're at moles of hydrogen, and we want to know volume. Because it's at ATP, we've got that molar ratio, the mole volume of gases at SATP. 24.8 liters equals 1 mole. So we can use that again either direction as we can with things in dimensional analysis. So in this case, we want to cancel moles and replace them with liters. So our moles needs to go on the bottom and our liters on top so that we can cancel those moles and end up with liters of hydrogen. So with dimensional analysis, remember, everything on top we're multiplying, everything on the bottom we're dividing. So 5 divided by 65.39 times 1, divide by 1, and multiply by 24.8 to get our answer. Don't forget about your significant figures. So we started out, the 5 grams is 2 sig figs, the molar mass is 4, mole ratio is exact, and the 24.8 is 3 sig figs. So when we're rounding this one, we want 2 significant figures. So that works out to 1.9 liters of hydrogen at SATP. second example here, we've got ammonia being produced by reacting hydrogen gas with nitrogen gas. So if we look at that, again, start with step 1, write our balanced chemical equation. So to balance that one, again, remember hydrogen is diatomic, nitrogen is diatomic, and ammonia is NH3. So to balance that, we're going to need 3 hydrogen to 1 nitrogen to 2 ammonia. So our known values in this particular case, we know volume of ammonia produced, we know temperature that the ammonia is produced at, and we know pressure that that's produced at, and we're looking for mass of hydrogen. So if we look at those values, volume, temperature, and pressure all relate to our ammonia, so I'm going to put it with the ammonia. Mass is the thing we're looking for with the hydrogen. So this time dimensional analysis won't work so nicely because we don't have SATP, we don't have STP, so we don't have a nice molar volume of our gas. Instead, what we're going to have to do is use our gas laws. So in this case, if we have volume, temperature, and pressure, and we're looking for moles, we want to use the ideal gas law. PV equals nRT. And we're going to want to rearrange that so that we've got N by itself. So divide by RT, we get N equals PV over RT. From there, we can plug our values in. So our pressure, 103 kilopascals. Our volume, 55.9 liters. Divide by, and remember RT is all in the denominator. I probably should have put brackets around this just to be perfectly clear. And definitely when you're calculating it in your calculator, be careful with what you're multiplying and what you're dividing. So R, that's our constant, 8.31 kilopascal liters, mole to the -1, Kelvin to the -1, or you could say per mole Kelvin, with them both being in the per part of it. And speaking of kelvins, we've got to change that temperature to Kelvin. So remember to take the 11 degrees and add 273 to get 284 kelvins for that temperature. So again, our units are going to cancel out here nicely, even though we're using a formula and not dimensional analysis, right? Kilopascals, and this is per, so that's divided by kilopascals are going to cancel out. Liters divided by liters, they're going to cancel out. Kelvins to the -1 and kelvins are going to cancel out, which leaves us moles to the -1, but that's in the denominator, right? So we've got 1 over moles to the -1, or 1 over per mole. So to bring that to the top, that's going to work out to moles, which is exactly what we were aiming for in step 2, right? Find our moles. So we work out that calculation. This is not our final step, so do keep any extra digits you've got. So 2.43 and a bunch of extra digits is going to be on your calculator. Gives us our moles of ammonia. Then we can move on to step 2 as usual, which is step 3, mole ratio. Right, so we're going to take that. And our mole ratio between hydrogen and ammonia, we want hydrogen on top because that's what we're looking for, and ammonia on the bottom so that it cancels. And our last step, convert to our desired unit. So we're looking for mass this time. So if we want mass of hydrogen, H2, multiply our 1.01 times 2, our molar mass is 2.02 grams in 1 mole. So we multiply by that. This gives us our overall results. So again, our calculator is going to display a lot of extra digits. But now we can round it because this is our final answer. So if we look at the values we started out with, we had volume, which was 3 sig figs. Temperature, be careful because we're going to use the Kelvin, right? Because when we add, we're going by placeholder. So 3 sig figs in our Kelvin, 3 sig figs in our pressure, 3 sig figs in our constant, 3 sig figs in our molar mass, exact value for our mole ratio. So when we round, we want 3 sig figs. So we're going to get 7.39. So hopefully all that helps you look at gas stoichiometry.